Okay, so I just want to take a quick look at building some Lightning Connect through OData to a backend SQL database. So here we're looking at our database. We have some tables, a product table, and a transaction table, which are the main elements that we're interested in. We have a large volume of transactional data and a reasonable volume of product data. Running a query across this data to provide a count shows that we have 152 product rows and about 1.2 million transactional rows of data. Moving into Direct Data Cloud, we can perform the setup as required to open up the OData connection. Standard database connection details are entered. On the OData tab, we need to use the Configure Schema button, which will build the schema for us. We select the schema within the database, and then select the required tables that we wish to include within Salesforce. So here we are interested in the product and in the transaction tables. Once we hit save, we are provided with the access URI. Pasting the URI into a browser gives us the OData service request document specification. This shows the tables, entities, which are included within this OData service. We can add a metadata parameter to the end of the URL, and this gives more detailed information. Moving into Salesforce, we now need to create an external data source. We give this a name and a label, and then select the appropriate type. Here we are selecting Lightning Connect OData. We then need to provide the URL of the OData service and set up the credentials for authentication. We're using a named principal, username and password, and the credentials are those of our Data Direct account. After saving, we can then press the Validate and Sync button on the external data source, and this will make the call out to the OData service to retrieve the schema. Here we can see the two tables that have come back, the product and transaction tables. We select these and press the synchronization button. Important to note here that we are only synchronizing the schema and not the actual data that's in those tables. Once the synchronization is completed, we see we have two external objects which have been automatically created for us. Drilling into the products object, we can see custom fields that have been created which match the schema of the SQL database. I've now additionally also created two custom tabs for these two external custom objects so that we can have easy access to the data. So here on the Products tab, on the list view, we hit go and we received a list of those products that we saw in the SQL database. The same over on the Transactions tab. Querying gets 1.2 million records here, but still we get a reasonably quick response. The first 25 rows of data are returned to us. Important, obviously, to remind here that this data does not exist within Salesforce. It's simply being fed to us through the OData service and the web service calls. The limitation on this data at the moment is that it does not relate to any other data within the system. So back into the external object, let's take a look at the transaction object. The field here, the product code, comes through from the SQL database as a standard text field. But we're going to change that. Clicking the change type, we can select one of the new field types, external lookup. This is to identify that this field is looking up to another external object as opposed to standard or custom object. So we've linked that through to the product object. So the transaction and the product object are now linked together, and we can drill down from one to the other. Also, we're going to take a look at the the customer ID field. So the customer ID field here relates to the actual account number that we have within Salesforce. And we're going to change this field type to an indirect lookup. Indirect lookup will look up to an account based on an external ID field value as opposed to a Salesforce standard ID field value. We're relating it to the account, and we'll specify the external ID field that we want to bind to. This is equivalent to a primary key, foreign key relationship within a traditional relational database. So let's take a look at an account now, see how this all hangs together. So drilling into Dickinson's, they have a customer ID 1234, and we can see in the related lists we have a transaction list, and within that there are 5 transactions that have been pulled through from the external data source. Over on another account here, let's take a look at Sovereign Fund. Same deal, customer ID is set, transactions are present. But from here, we've built those relationships between the transaction and product objects so we can drill through to the product and view the product page. And on the product page, we can see all the related transactions that there have been. So this is really starting to make some sense now. External objects that relate into standard objects and that can relate to one another to build a full data model picture. So over to another account here, this time one that hasn't got a customer ID set. And this shows the power of the indirect lookup field. There are no transactions relating to this account. But as soon as we enter the customer ID and hit save, and the page refreshes, the transactions will be related to the account. That transactional data is always available irrespective of the data integrity. Okay, so back into the database now. Let's just prove the real-time nature of this external objects, external data source, OData integration. Let's insert a new transactional record. 333 is the amount. Let's choose a currency code, one that probably doesn't exist. Relate it to a product code and specify a transaction ID. So that record is now saved to the database. Let's switch back into Salesforce, refresh United Oil account to which this is related. This new transaction is related, and let's take a look. So now we've got 5, previously we had 4, and there's the new transaction amount 333, currency code AZZ. So I'm impressed with this new Lightning Connect OData integration approach. I think it shows that we never need to build a nightly batch job.